So again, I want to welcome everybody to tonight's webinar on Tropical Storm Elsa. I'm Joe Deli Carpini, the Science and Operations Officer, and with me is Rodney Chai, one of our meteorologists. So Rodney will get us started to take us through this review of Tropical Storm Elsa. Rodney, go right ahead.
Well, thank you so much, Joe. And like Joe mentioned, it seems that Elsa was an eternity ago. Over the past month, we really haven't had much tropical activity, and the tropics have been kind of very quiet. And it's a welcome relief for not just for us in the forecast office, but also for for many communities. There's been a lot of rain. We don't need a tropical system right now. Here what you're looking at is really a satellite composite, and you can see you have the nighttime image over alongside with the daytime visible satellite imagery, and you can see how this just kind of shows you how it's kind of a little bit fast, but you can kind of make out how Elsa traveled up the eastern seaboard and eventually made landfall along the south coast and impacted southern New England. And this is an overview of Elsa in southern New England. The main impacts for us were the heavy rainfall and flooding. Prior to Elsa impacting southern New England, there was a very active stretch of weather pattern, which means that the ground was saturated, the river levels are higher than normal, and the climate sites, we have 4 climate sites: Boston, Providence, Hartford, Connecticut, and also Worcester. And all the climate sites, reached the top 10 wettest July on record after Elsa. And for those keeping track of the rainfall records, all the climate sites are currently in the top 5. Because we had more rain after Elsa. And there were also some higher wind gusts recorded, up to 67 miles per hour. But thankfully, the number of power outages were a fraction compared to recent tropical storms like Isaias and also a decade ago, Irene, for those of you who remember. And the duration of the strongest winds were also much shorter, which, again, thankfully contributed to relatively low number of power outages. And this is the surface wind view of Elsa. And, by the time this map was made, it was already a post-tropical cyclone. And you can see the track of Elsa, how it just kind of hugged the Florida coast before making landfall in the Florida Panhandle, went inland and again hugged the eastern seaboard, went out to sea again, and then kind of skirted Long Island and then made landfall along the south coast, and again before emerging in the Gulf of Maine as a post-tropical cyclone. And here's the wind view with the wind speed highlighted. The orange color represents tropical storms wind speed. That's and then that's actually prior to making landfall in the Hispaniola was a hurricane, and it actually briefly re-intensified into a hurricane just before making landfall in the Florida Panhandle. And this is just a snapshot of the all the warnings that were in place, and that was around 1 p.m. on Friday, July 9. So you could imagine it was a busy day at the office. So we had, the bright red colors, that is tropical storm warning, and areas highlighted in the darker red color, that's a flash flood warning. And in addition to the flash flood watch that is was issued area-wide just because again, the grounds were saturated, the river levels were running high, so it doesn't really take much more rain to cause flash flooding. And there was also a flood warning that's that either is the the river levels going into flood stage or a longer duration flood event compared to the flashy nature of flash flooding. And this is the basically the cloud top temperature you're seeing here, and you notice that there's around the center of the circulation of Elsa, there's the cooler cloud top representing upward motion of air. So that's that's typically what you want to look for when you look at cloud top temperature images of on a satellite. And it's the same, if you look at the visible satellite image of the storms going on right now in southern New England, you will notice the cooler cloud tops. And this is a really cool image from, I believe it's from the International Space Station, looking at Elsa from way high up in space. So you can get a bird's eye view of the tropical storm. And this is a visible satellite loop of Elsa as it made its closest approach to southern New England. And notice kind of you can roughly make out the center of circulation. It's not very, it's not like an eye-like shape, because by the time it's a little bit more disorganized, and it's transitioning to a post-tropical cyclone as it gradually loses its tropical characteristics. And this is a tweet showing how Elsa went from the tropics towards Greenland. And you can see how it, it's just really cool as you track the history from the Caribbean into all the way to the Arctic. And this is a slide showing the peak wind gusts. Again, the highest wind gust recorded was 67 miles per hour. A lot of coastal areas saw gusts anywhere from 45 to 55 miles per hour. And again, because the duration of the strongest winds was relatively short, the wind damage thankfully was relatively minor. And here's a look at the power outage map from MEMA, Massachusetts Emergency Management, and 13,600. That's a fraction of what we experienced from Isaias and Irene, where power outages were in the hundreds of thousands. And just to recap, the common characteristics of New England tropical cyclones. So every storm would undergo what we call a transition from tropical to extratropical, meaning winter storm-like characteristics upon approach towards New England. And this is due to interaction with the jet stream. This, as a result of this interaction, there's rapid acceleration up the coast. And also heavy rainfall usually focus along and west of the storm track. So the storm track is pivotal in determining where the heavy rain axis is going to be. And also the high winds will be focused east of the track. And in addition, the storm surge would also be focused east of the track, with the greatest surge depths occurring on the upper reaches of the south-facing bays and inlets. So, you could imagine, with the right track, places like, say, Narragansett Bay, could experience a storm surge and, lead to all kinds of issues with the coastal communities along the south coast and the bay. So in a nutshell, we spend a lot of time, and also along with the experts at the National Hurricane Center, to determine the track of the tropical system. And so when we talk about rapid acceleration northward, the average forward motion for storms impacting New England is around 33 miles per hour. And the Great New England Hurricane of 1938 made the trip from Cape Hatteras, North Carolina, to Providence in just 8 hours. And at that time, the forward speed at landfall was, kind of between 50 to 60 miles per hour. And in comparison, Tropical Storm Elsa was 31 miles per hour. And the table on the right shows you, some of the hurricanes that impacted New England, and their average forward motion. And as we talked about earlier, there's one of the biggest concerns for Elsa was heavy rainfall, and this map shows you the 7-day observed precipitation, and so you can see, as with most tropical cyclones that affect southern New England, the heaviest rain fell along and west of the storm's track. So the black line represents the approximate track of Elsa, and unsurprisingly, the heaviest rainfall was to the left of this storm track. And here's a closer look at the rainfall totals. And this was just more confined to just the rainfall associated with Elsa. And you can see, so what you're seeing here is actually the radar estimated rainfall, which is shaded, in the bright colors. And the numbers that you see overlaid on the map, those are actually observed rainfall. And those are rainfall reports that from people like you, with your weather stations, and also the weather stations from the automated sites and the climate sites. So, all of your reports are very useful. So that's why there's some discrepancy between the shading and the value that is indicated on the map. But overall, they do a pretty good job of being consistent. But you can see that, and again, the highest rainfall was north and west of the track, again denoted by the black line. And in fact, there's a bullseye from somewhere across southern Connecticut into central Massachusetts. And this is showing the rainfall minute by minute, and you can see kind of this map is pretty cool. It kind of shows you the timing of the heaviest rainfall, and it was really between around a 6-hour period that the heavy rain actually, most of the rain fell, and that was actually what we expected and communicated to the emergency managers and the public, because it was a very progressive event. So even though the rainfall rates were pretty high, I mean, it's 1 to 2 inches per hour, because the heaviest rainfall is going to be in the 6-hour period. So any flooding issues would be kind of relatively short. And this is taking a look at the Norwood Memorial Airport 1-minute rainfall, and you can see at one point the rainfall rate was 4 inches per hour, and you can imagine low-lying places and then the small creeks could really burst their banks relatively quickly, and so there were a bunch of flash flood warnings. So this is a screenshot from the Northeast River Forecast Center website. And so the icons in green, that's basically no flooding. Yellow means that it's nearing flood stage, but not flooding yet. Then the orange icons are minor flooding, and the red ones indicate moderate flooding. And you can see there were some gauges that actually light up in red. So, there was quite a bit of flooding going on as the heaviest rain rates occurred. And this is taking a look at the hydrograph of the Willimantic River at Coventry. And you can see, just how quickly the river levels rose, from way below flood stage to all the way to moderate flood stage. And you're talking about, that's a relatively short amount of time. So, that's why it's really important. And sometimes if the basin is a little bit bigger, it takes time for it to respond to all the rains, because all the smaller creeks would eventually drain to the larger basins, and you may see a delayed response. So sometimes even after the heaviest rain has occurred, but you live by, a kind of like a bigger river or brook, you might want to pay close attention to the river levels change. And this was actually ground truth. This is a video sent to us by Tristan, who lives right by the Willimantic River at Windham, Connecticut, which is about 10 miles from Coventry, Connecticut. And this is looking at July 10 at 6:15 a.m. And just look at how how close the water is to the window. So that's pretty scary. And on the left, that's Route 146. Some of you may be familiar with this road, and this leads to Worcester. And you can see, wow, this is just pretty incredible amount of flash flooding. And like to tell folks, and don't drive through flooded roadways. Turn around, don't drown, because you never underestimate the amount of rain of flooded roadways that can, just cause a vehicle to stall, in the worst case scenario, sweep away your vehicle. So always make sure don't drive through flooded roadways. And on the right hand side, there's a couple of people looking down at the flooding from on top of the building. And again, that's in Worcester. So there's quite a bit of flash flooding. And more pictures from Worcester, just pretty incredible images. And this is outside of our coverage area, but this Elsa actually caused all kinds of flash flooding in New York City, including Manhattan, and there was a lot of water gushing down into the subway stations, and that's really, again, pretty scary. And this is taking a look at drone footage of the flooding in downtown Meridian, Connecticut, and which is about 20 miles southwest of Hartford. And just look at, again, the scale of the flooding from Elsa. Just more images. And, the road basically turned into a river. Cars submerged underneath apartment buildings. And a fun fact, remember I talked about how Elsa, went all the way to Greenland as a post-tropical cyclone. But a fun fact is that it actually produced snow in parts of Greenland. So just really impressive system. And right now, I'm just going to pass the slide to Joe to talk about forecast challenges in the second half of the presentation.
Okay, thanks, Rodney. So we'll go through some of the challenges with the forecast. First of all, we're just going to start taking a look at some of the key features that, why did Elsa come up the coast and not offshore? So when we look at the jet stream level, this is at about 34,000 feet. The day before, you can kind of see Elsa hanging out around here in the Bahamas. There's a few key features that we noticed. First was this trough or little dip in the jet stream right here across the Great Lakes. There was also kind of the opposite pattern, a ridge or high pressure north of Elsa, and then a ridge over the Rockies. So it was these three features that kind of steered Elsa up the coast, and we'll get into a little bit of why that is. But typically, as Rodney mentioned, we talk about storms going post-tropical or extra-tropical, like a winter storm. It's usually this presence of a jet stream up here in southern Canada that will begin that process as the tropical system works up the coast. So pretty much what happened is this trough deepened a little bit. It kind of caused the flow to turn more southerly. This ridge strengthened a bit, so you kind of imagine the flow turning up the coast. And this ridge out in the west also strengthened, so it kind of lifted up the ridge here, caused these things to dive a little more, and we had a pattern that ended up kind of like this, going right up the coast. So it was those three features. And we kind of look at these with winter storms, too, to get a winter storm coming up the coast. Usually there's a very large ridge out here in the Rockies and some sort of trough or cutoff low here in the east. So a very similar pattern to that. So if we come down a little bit at 500 millibars, you can see reflections of what we just showed. This is a little bit lower in the atmosphere, but you can see this trough here in the Great Lakes, this ridge kind of just ahead of Elsa, and then a ridge, kind of a broader ridge here over the northern Rockies. So it was these three features that helped steer Elsa right into southern New England. And if we just take a look here, these are the surface maps going from Friday onward. You can see the tropical storm moving off the New Jersey coast, across Long Island, and right into southeast Mass before going up into Maine. So it pretty much followed that upper flow, which was going parallel to the East Coast. And this was some of the wind timing. You probably looked at these as the advisories were coming out for Elsa. This was the most likely time of arrival of tropical storm force winds, which worked out pretty well. It was 8 o'clock in the morning. Friday was the forecast here in Connecticut, and that was about the time that they got underway. Most areas from about 8 in the morning till 2 or 3 in the afternoon had tropical storm force winds, and then it just diminished rapidly during the afternoon and the evening. These were some of the probabilities. This was looking at 120 hours. This is 5 days out, which wasn't a bad forecast. And what this takes is pretty much all of the weather models that we have and comes up with various probabilities. But you can see at the time the storm was off of the Florida Gulf Coast, the highest probabilities were kind of centered near Nantucket and Cape Cod, which turned out to be pretty much correct. Maybe there was a little bit of a wiggle here as we got closer in time, but overall the forecast remained about the same and showed our big wind threat was really Rhode Island, southeast Massachusetts, east of the storm track. So we also take a look at our soundings, and if you're not familiar with them, we've showed these a few times. This is what the weather balloons measure as they go up. So the red would be temperature going up in the atmosphere. The green is dew point, so we're looking at moisture. Where it's closer together, there's more humidity, and where they're a little further apart, there's lower humidity. So a few things that we noticed, this is Wallops Island, Virginia, the day before, kind of setting the stage for us as well. There's a very high layer above freezing. So here's the freezing line here. It's up at about 15,000 feet or so. That's pretty high. It's typical of the summertime, actually about 14,000. And when we have high freezing level, high moisture, that's very supportive of heavy rain. There was also a little bit of instability for thunder. We look at potential energy here. The Cape was showing just over 1,000, so that's pretty respectable for a tropical system. And also some wind shear. So again, change direction with height. So we're looking at east to southeast winds in the low levels, going to south and then southwest as you get higher up. So that turning is, capable of producing water spouts or tornadoes. And actually, there were several water spouts reported across the Mid-Atlantic, not so much up here in New England, but from about south of Long Island down through about Virginia offshore in the coastal waters. Then if we go to Friday morning, looking at the Albany sounding, as the storm was getting closer, a similar pattern, pretty high freezing level, 13,000 feet. You can see it's pretty moist all the way up. So we're, again, supportive of heavy rain. Not quite as much instability for thunder, a little bit less here on this cape, as we call it, about 200, and weaker shear too. You can see the winds, first of all, are lighter in speed, only about 10, 15 miles per hour from the south and then more of the southwest. So not a lot of turning. So the expectation was, as the storms reached Connecticut, Rhode Island, Massachusetts, definitely less of a tornado threat and more of a heavy rain threat. So our messaging in advance of Elsa focused on what Rodney talked about, the flooding, rain, and wind impacts, and marine interests as well. Again, the tornado waterspout threat was fairly low, and really no threat from coastal flooding or storm surge, which I'll talk about here in a second. So we were communicating these kind of key points that the National Hurricane Center also does. The main threat was flash flooding and strongest winds near the coast, especially Cape Cod and the islands, and really kind of a in and out quickly. As we like to say, in for breakfast, out for dinner. It was arriving Friday morning and departing in the afternoon, so it really didn't last too long at all. And as I mentioned, really no threat of coastal flooding. The astronomical tides were fairly low. You can see the tides for Boston. Flooding normally begins about 12.5 feet, and the tides were only running about 9 to 10 feet. And because the southerly winds, there was really no surge off the water from the east, at the most about a foot. So that really wasn't going to do very much. And if we look at the south coast, there was a little bit more of a concern there with the southerly flow that brings the water up into the bays and inlets. About a 2-foot surge, but even that really wasn't expected to cause much of a problem, again, because the astronomical tides were fairly low. And also you can see it was coming in at low tide. So here's Friday morning. Low tide was about 8, 9 in the morning. So it really was coinciding with the better time of the day. So just to go back to the tornado threat, why weren't we so, concerned also? We can see on our model forecast here, this is called updraft helicity or spin. So think about it, it's kind of spin in the atmosphere. And the models were definitely showing more across southeast New York at this time frame, and earlier was down across Delaware and Virginia. So really less of a threat as we reached into New England. And again, limited instability too, only very slight instability with a tornado threat across perhaps Long Island Sound, but more so down to the south of our region. So here's overnight. This was at 4:40 in the morning. This is a probable waterspout. There was no confirmation. Nobody was out there, but you can see this little bit of a hook or an eye on the left, and you can definitely see the greens against the reds here on the right, which is indicative of a pretty tight circulation. So this was a probable waterspout off of Toms River, New Jersey, during the early morning hours. And as you can see, if we look at kind of our low-level instability and spin, what was happening, these are kind of analysis maps. So at 4 in the morning, you can see they're both kind of co-located here off the New Jersey coast from the previous image. And then by 7 a.m. Was a little bit more to the north, but still, we really weren't in a favorable area at all at that point by 7 a.m. And then moving forward by 10, you can see here's your spin in the blue, kind of the instability in the reds outrun it. So they're not located together anymore, and you can see that as well by 1 p.m. So we had the spin, but just not enough instability to really generate any kind of waterspouts or even weak tornadoes as Elsa moved through. And just looking at some of the other guidance, this matched up pretty well with what Rodney showed earlier on the rainfall, kind of eastern Connecticut into northern Rhode Island, eastern Mass, maybe displaced a little bit further to the east than what happened. It was probably more out to here, but overall fairly accurate. And this was a forecast that was about 24 hours prior. And just to show again the comparison of observed rainfall on the left and the model forecast rainfall on the right. Not too bad. So we'll finish up just a couple of nice pictures here. This was the day after Little Compton, Rhode Island. Still a lot of rough surf from leftover swells. So you can see it's nice and sunny out the day after. It's kind of a warm and humid day as we were in kind of a tropical air mass, but there's a pretty shot there. And I think Rodney also had one from rip currents on the south coast of Massachusetts. You can see here everyone's surfing in the water with the high surf, but certainly a high danger of rip currents throughout, and many beaches were closed on Friday and also into Saturday as well. So you can see one of the rip currents actually here, where the foam is kind of heading out from the shore. Let's see, let this loop go through again so you can see it. But see one there, rip current. And let's see, is there one more? Might be. Maybe one more over here. You can definitely see that right there, that foam coming out. So rip currents hung around for a couple of days, which is pretty typical as well. They don't usually depart too quickly. So with that, let's go through, Rodney and I will go through some questions. Let's see. So the storms are moving through right now. Actually, it's darkest night in my house in Norwood. Fred says, scary winds in Newton now. Okay, so we know that. Hopefully no damage up there, Fred. So question from Ronald. Is it my imagination that the jet stream's fronts this summer are stagnant, not much push out to sea? Maybe one of the reasons for the excessive day-after-day humidity, heat, and rain. Yeah, actually, Ron, that's been the pattern this summer, that trough kind of staying in the east and been persistent. So we've been in a warm and humid pattern, a lot of showers and thunderstorms, and this does put us in a higher risk for tropical systems as we head through later summer and August, September, instead of being steered out to sea. So we'll have to see if the pattern holds. If it does, we have definitely an increased risk of more tropical systems, but kind of just remains to be seen if this pattern will stick around or kind of transition to something else. So we will see. Let's see. Going through some more questions here. Earlier one from Melissa out in Auburn. Lots of rain and wind, no hail. So that's good. Barely any lightning or thunder. Interesting. Let's see. Ron mentioned that Isaias went up the east coast of Florida, Elsa up the west coast. That's correct. John had a question. I think he's offline. Hopefully he didn't lose power. But will an extratropical system show cold cloud tops like an Elsa? Yeah, often it will. If you look at a winter storm, a lot of you get those colder cloud tops where the heavier bands of snow are forming. So it just means really higher cloud tops. Colder temperatures mean higher tops. Let's see. Let's go around to some more questions here. Let's see if I can get to the next one. Okay, let's see. Max wanted to know about last Wednesday's lack of storms. Yeah, we're going to talk about that. We've got a webinar coming up in August, Max. Actually, Rodney and I just finished the presentation for that. So there are a couple of things going on that the models really didn't pick up on. So stay tuned for that, Max. We will have that coming to you. From Robert, any chance the jet stream will change and give the West Coast some rain relief? Hope so. A lot of times our weather is in patterns of about 4 to 6 weeks, sometimes a little longer. It just remains to be seen whether we start to get under more of a ridge here in the east and dry out, and the West Coast gets its turn with some rain, hopefully, because I know they definitely need it. Let's see. So a few more pattern change questions. We'll kind of see how that goes. Let's see. From Sebastian, a comment. Tornado threat was somewhat mitigated, as you stated, because of how much moisture content there was in the atmosphere. If there was more dry air in the lower levels, then the CAPE or instability would have been more substantial. Yeah, but typically with a tropical system, you don't get that dry air because the air mass is of tropical origin. So it's usually very moist all the way up. It would be unusual for a tropical system to have dry air aloft with it, unless it really had gone extra tropical and the jet stream kind of provided that, Sebastian. But yeah, that's a good point. Typically for severe weather, that's what we look for. But not so much in tropical. We tend to see low instability, high moisture, and high amounts of wind shear. So just didn't have the instability this time. So let's see. Looks like about it. So Rodney, at this point, I think what I'm going to do is we'll pause our recording.